involves some concepts we learned from last unit, the centripetal acceleration. Okay, but it should be simple. There is a straightforward relationship between the centripetal acceleration and the speed, right? So if you calculate part A, part B is quite straightforward. And then we have to relate it to the tension. Of course, that means we have to do some kind of force analysis to relate the velocity to the force. Okay. So, something like this. A pendulum is released from the horizontal position. The length of the pendulum is 2 meters. What is the mass of the pendulum?
1.5.
1.5. Okay. When it makes an angle of 30 degrees from the vertical, the motion is something like this. Okay. So at this point, this is our final point. We want to find the first A, the speed V. Now, let's look at how can we find the speed V. Do you have any suggestion? What kind of equation can be, what kind of method can be applied here?
Yes, with the centripetal acceleration.
What?
Something to do with the centripetal acceleration.
No, you need angle. Then, from velocity, you can find out centripetal acceleration. You cannot find centripetal acceleration first and to calculate the speed. You need to find speed V first. What do you say? Okay, can you see this is a simple pendulum swinging process. So it's mechanical energy conservation. Okay. So for this part, somehow you need to think about the process. So before you even look at which quantity you are calculating, you need to always think about, okay, this is your swinging process. So you probably have the mechanical energy conservation. If this is the collision process, you may have the momentum conservation. If it's a dropping process, mechanical energy conservation. If it's a compressing process of spring, you may have mechanical energy conservation. So each problem, you need to think about what kind of process you are talking about. And then you pick up the equation. And then you try to look at, in this equation, can you try to relate the one of the terms in the equation to the quantity you're asking. And here, of course, you have. Because in the mechanical energy conservation, you may have a term like 1/2 mv squared, which will give you V, right? Okay? So this is the mechanical energy conservation process. This is our initial state A. This is our final state B. So, of course, we know some quantity here. What do we know about velocity here?
0.
0. So let's call it VA equals to 0. Okay? And VB, of course, that's the quantity we want to find. The velocity at this point. And to apply, okay, by the way, what kind of potential energy involved here? Gravitational potential energy. So we have to know the initial height and the final height. Okay. And you want to choose some zero reference point. Where you are going to choose as a zero reference point. You can choose either top or
where B is.
B is, okay. Let's choose here as 0. Then the final height YB will be 0, right? And you still need to figure out the initial height YA. It's not directly given, but you remember we have some problem like this before. You should be able to figure out the height from the trigonometry, right? Do you remember how to do that? No. Okay. So this is the height. Okay. So this is also the height we are looking for, right? And this height, how can we calculate this height? In this triangle, if you know the hypotenuse, which is 2, and you know the angle, so of course you can calculate this, right? So this is the height YA should be 2 multiplied by cosine 30 degrees, right? Okay. So this is square root of 3. Okay, square root of 3 is about 1.7, right? Okay, so that's the initial height YA. Any question here? And then you have VA, YA, YB. Of course, you can calculate VB by looking at the mechanical energy conservation. So you have KA plus UA equals to KB plus UB. Okay. How many zero terms do we have? Which one?
Should be 2. 2?
Yeah, 2. Can you tell me which 2?
Is a,
VA
VB.
equals to 0, so that means which term vanishes? KA, right?
Yeah, UB.
Initially kinetic energy. YB equals to 0, which term vanishes?
UB.
UB. So UA equals to KB, that means MG YA equals to 1/2 MVB squared. And in fact, I don't even need the math here. So VB squared equals to 2GYA. So VB equals to square root of 2GYA equals to square root of 2 times 10 times 1.7 equals to, oh, sorry. Okay, can you give me this number?
5.8.
5.8 meter per second. Okay, so that's the velocity at this point. So that's part A. And then part B should be very straightforward. How can we calculate the centripetal acceleration? By definition, centripetal acceleration equals to V squared over R. So here what is V?
5.8.
VB, 5.8. What is R?
2.
The length of the string, 2. So you can get some number. Okay, we need that number. I think, no, probably doesn't need it. It will be here. And then, we can calculate part C. You want to find the tension. Tension, yes, we do need that number. Can you give me the number here?
That's 16.82.
16.8.
8.
Okay. Now, let's see if we want to calculate the tension. So there is a tension here along the street. Okay. And from the force analysis, that's the only force can provide the centripetal acceleration, right? Oh, no, I'm sorry.
No?
There is another force cap provides the centripetal force. You have gravity. The gravity can be decomposed to give part of the contribution to the centripetal acceleration. So what you have is, if I draw the graph here, you have gravity, you have the tension, you need to decompose the gravity. This is Wy, this is Wx. So this is our y direction, this is our x direction. Okay. This is t. So we will only need the equation along y direction, right? Okay. This is 30 degrees, so this angle is 30 degrees. So our equation along y direction should be P minus Wy equals to MAY, right? Okay, any question about writing down this Newton's second law? Okay, I skipped a few steps here. Okay, so that should be some concrete process you're familiar with. This tension subtracts this partial weight equals to the acceleration on that direction, right? Okay, so Wy, of course, if you do the decomposition, how can you express Wy? This is W equals to mg. Mg cosine 30, right? And Ay, what's Ay here? Along that direction, what is the acceleration? 0. Is it 0? Think twice about that. 16.8. Please note that this is not a linear motion, a circular motion. So it must have some centripetal acceleration. Now y direction is our centripetal direction. So Ay equals to AC, right? Okay, for circular motion, remember, if I do this decomposition, in fact, Ay equals to AC, Ax equals to AT. Okay, don't forget what we have learned for the circular motion. So, if we put that, we get T minus mg cosine 30 equals to MAC. But we know all these quantities, mg, 30 degree, MAC. So T equals to mg cosine 30 plus MAC. Okay. If you put all these numbers, you can get the tension. So, okay, so this is kind of problem to put a lot of things together. Okay, we have learned before. Any question here?